You know, we all like to think we're in control, in the driver's seat of our own lives. But then, boom, chaos strikes. A project just collapses, a plan unravels, and we're left standing there wondering what in the world went wrong. We call it bad luck, right? A fluke, some unfair twist of fate. But what if it's not random at all? What if all that chaos is actually a system with its own hidden logic governed by a set of invisible laws? Today, we are going deep. We're not just going to list off some concepts. We're going to explore the fundamental operating system for reality itself. We're going to uncover 7 laws, from Murphy's to Pareto's, that are quietly running the show in our lives. And look, understanding them isn't about trying to avoid failure. No way. It's about getting the cheat codes to navigate all that complexity and actually engineer your own success. Okay, let's dive right in. So our story kicks off in the vast, sun-scorched desert of Edwards Air Force Base. The year is 1949. The Cold War is heating up, and the jet age is screaming into existence. You've got pilots pushing aircraft faster than the speed of sound, flying into a realm of physics where, frankly, nobody really knows the rules. And this created a terrifyingly urgent question for the U.S. Air Force. Just how much force can a human body actually take? I mean, if a pilot has to eject at Mach 2, are they going to survive that wind blast? Will they survive the insane deceleration when a parachute snaps open? Or will they just, disintegrate? They had to find the absolute limit. And the answer? Well, it was going to come from a series of incredibly audacious and brutal tests. And the man they picked for this ordeal was a flight surgeon, Colonel John Stapp. And get this, he wasn't just some passenger. He was the lead researcher, and he volunteered for his own experiments. Just try to picture this. Stapp is strapped into this open-air rocket sled. They called it the Gee-Whiz. In just a few seconds, rockets blast him up to 632 miles per hour. That's faster than a bullet from a .45. Then, a hydraulic braking system slams the sled to a dead stop in just 1.4 seconds. The force is just unimaginable. We're talking over 46 Gs. It's like hitting a brick wall in a car going 120 miles an hour. His vision just completely vanishes as capillaries in his eyes burst, blinding him for a bit. He cracks ribs, breaks his wrist, suffers retinal hemorrhages. He was, quite literally, a human crash test dummy, all in the name of science. Now, the entire reason for going through this monumental physical trauma was to collect data. They had this brand new, state-of-the-art harness kitted out with all these expensive strain gauges that was supposed to measure every single brutal millisecond of that impact. So after they unstrapped Stapp, bruised, bleeding, but amazingly alive, the engineering team rushes over to the readouts. They're expecting this treasure trove of groundbreaking data that's going to save pilots' lives. And what did they find? Absolute silence. Blank screens. Zero data. A junior technician, in a moment of just catastrophic carelessness, had installed every single sensor perfectly backwards. The most expensive, high-risk, painful experiment of the day had produced exactly nothing. The man who had actually designed that sensor harness was this brilliant development engineer, Captain Edward Murphy. He'd flown in from Wright-Patterson Air Force Base just to watch the test. And when he saw the complete, total failure, he didn't scream, he didn't rage. He just walked over to the project manager, looked at the useless harness, and made this dry, cynical observation about the technician who'd messed it up. He said, if there is any way to do it wrong, he will find it. And right there, in that single moment of profound, expensive failure, the first and most fundamental law of our system was born. And yep, that simple observation became Murphy's Law. Anything that can go wrong will go wrong. Now, most of us just misuse this, right? It's like a pessimistic sigh, a way of saying the universe is against us. But that's a huge misunderstanding. See, what's really interesting here is that Murphy's Law isn't a curse, it's a fundamental principle of complex systems. It's really about entropy and probability. The more parts a system has, the more ways it can fail. It's not just a possibility, it's a statistical inevitability. Think about the 1986 Challenger disaster. The engineers knew the O-rings, a simple rubber seal on the rocket boosters, could fail in cold weather. But the pressure to launch was just immense, so they treated this known potential failure as just an unlikely risk. But on launch day, it was freezing. The statistical certainty of Murphy's Law kicked in. The seal failed, the shuttle disintegrated, and 7 astronauts died. All because a possibility wasn't treated as an inevitability. So here's the crucial takeaway. Murphy's Law is not an invitation to despair, not at all. It is a direct command for paranoid, forensic preparation. It teaches you that hope is not a strategy. I mean, think about it. Successful engineers, pilots, surgeons, they don't just hope for the best. They assume the absolute worst and then they plan for it. They rigorously hunt down every single point of failure and they build in redundancy. You don't beat Murphy's Law with optimism. You beat it with a backup system, a failsafe, a contingency plan. You assume the O-ring will break and you design a system that works even when it does. That's the real powerful lesson from those blank data screens out in the desert. Okay, so Murphy's Law teaches us to get ready for the inevitable arrival of chaos. But what happens when you're already smack in the middle of it? You know, when a problem feels so huge, so tangled and overwhelming that you don't even know where to start. Well, now we're going to shift from just understanding the problem to building a practical toolkit for action. These next few laws, these are your instruments for dissecting chaos and bringing back some order. All right, our first tool in the kit is Kydland's Law, and its power is in its simplicity. If you can write the problem down clearly, then the matter is half solved. Now, this isn't just about making a to-do list. This is a psychological weapon against that paralysis you feel when you're totally overwhelmed. The act of externalizing the chaos, literally pulling it out of the swirling mess in your head and pinning it down on paper, it transforms it. It goes from being this terrifying, shapeless demon to a concrete, analyzable puzzle that you can actually solve. And for a perfect example of this, let's jump back to 1935. The U.S. Army Air Corps was shopping for its next long-range bomber. Boeing comes in with its new prototype, the Model 299, which we now know as the B-17 Flying Fortress. I mean, this thing was a technological marvel. 4 engines, variable pitch propellers, retractable landing gear, totally revolutionary stuff for the time. So, on its big demonstration flight with the Army's chief of test flight at the controls, the plane climbs steeply, it stalls, crashes, and explodes in a massive ball of fire. An investigation concluded the plane wasn't even faulty. It was just, and I'm quoting here, too much airplane for one man to fly. The cockpit was so complex that the pilot had forgotten to release one single crucial control lock. The Army was ready to scrap the whole project and buy a simpler, worse plane from Douglas. But then, a group of test pilots came up with this ridiculously simple solution. They didn't redesign the plane. They took all that overwhelming complexity, and they just wrote it down. They created a pilot's checklist for takeoff, flight, landing, and taxiing. And this just perfectly illustrates the point. With that simple checklist, the unflyable plane became one of the safest and most iconic aircraft of World War II. They defined the problem on a piece of paper, and in doing so, they solved. All right, so you've used Murphy's Law to prepare for failure. You've used Kydland's Law to define the problem. Now what? Now you have to act. And this brings us to Gilbert's Law, which is this really stark principle of execution. The biggest problem with the job is that no one tells you what to do. This is the law of initiative. It's about competence. It's about taking ultimate responsibility for the outcome, not just checking off tasks on a list. At the start of the Spanish-American War in 1898, the U.S. desperately needed to communicate with the leader of the Cuban insurgents, a General Calixto Garcia. The problem was he was hidden somewhere deep in the jungle mountains of Cuba, and nobody knew exactly where. There were no phones, no telegraphs, no safe way in. President McKinley needed someone to deliver a critical message. So, an intelligence officer named Andrew Rowan gets summoned. He's handed a letter, and his only instruction was, get this to Garcia. Rowan didn't ask for a map, he didn't ask for a guide or for supplies or for clarification. He just took the letter, sealed it in an oilskin pouch, strapped it to his chest, and left. 4 days later, he lands on the Cuban coast in a small boat, meets up with rebels, vanishes into the jungle for 3 weeks, navigates through enemy territory, and pops out on the other side of the island, having delivered the message. So the key point here is this. Rowan understood that the how was his problem to solve. The outcome was the only thing that mattered. Gilbert's Law really challenges us to be that person, the one who delivers the message to Garcia, to stop waiting around for instructions and start owning the result. Okay, you have your mission. You're ready to execute. But how long do you give yourself? Well, this brings us to one of the most profound, most universally recognized laws of productivity, Parkinson's Law. It states, simply, that work expands to fill the time available for its completion. And this isn't just about procrastination. It's about how the perceived scope and complexity of a task literally inflate to match whatever deadline you set for it. Okay, picture this. It's the heart of the Great Depression. The world economy is in ruins, and 2 auto execs, John Roscoe of GM and Walter Chrysler, are locked in this race to the sky to build the world's tallest building. The deadline wasn't just ambitious, it was borderline insane. The team behind the Empire State Building had to go from groundbreaking to grand opening at a pace that had never been seen before. Because the timeline was so ridiculously tight, there was zero room for inefficiency. They had to pioneer revolutionary techniques. Steel beams were ordered to exact length and arrived on site, marked with their floor number, hoisted directly from the truck into place, sometimes just 80 hours after being forged in a mill in Pittsburgh. They built an entire miniature railway inside the building to move materials faster. They even built cafes on the unfinished floors so workers wouldn't waste time going down for lunch. And the result? This 102-story icon was finished in just 1 year and 45 days. It's a feat of engineering and logistics that is still astonishing. Why? Because that radical deadline forced radical innovation. Look, if you give yourself a year to write a book, it's going to take a year. If you give yourself 90 days, you'll find a way. You compress your timeline to amplify your focus and force the result. So, we've built our toolkit for action. We know how to prepare for failure, how to clarify our problems, take initiative, and execute with killer efficiency. But frantic action without a guiding philosophy, that's just wasted energy. So now let's move to our next set of laws. These aren't about what you do in the moment. These are about the strategic mindset you have to cultivate for long-term wisdom and success. First up in our strategic set is Wilson's Law, and this is the foundational principle for creating real, sustainable value. It states, if you prioritize knowledge and intelligence, money will continue to come. This totally flips the conventional script. It argues that you shouldn't chase money directly. Instead, you should relentlessly pursue deep, irreplaceable expertise, and then money becomes an inevitable byproduct of the value you can create. There's this legendary story about this, maybe it's true, maybe not, but it makes the point perfectly. Henry Ford's massive River Rouge plant had this colossal, complex generator that just ground to a halt. The entire production line stopped. Ford's own expert engineers were totally stumped. So desperate, they call in the preeminent electrical genius of the era, Charles Proteus Steinmetz. Steinmetz, this quirky, brilliant guy, shows up and spends 2 days just walking around the silent giant, listening, tapping, making calculations on a notepad. Finally, he pulls out a piece of chalk, climbs up a ladder, and makes one single small X on the side of the generator's casing. He tells the engineers, cut open the casing and replace 16 windings from the field coil at that exact spot. They were skeptical, but they did what he said, and the generator roared back to life. Ford was thrilled until he got a bill for $10,000. He sent it back demanding an itemized breakdown. Steinmetz returned a new invoice. It read, making chalk mark on generator, $1. Knowing where to put the mark, $9,999. This just brilliantly illustrates that your value isn't in the labor you perform, it's in the knowledge you possess. So, having deep knowledge is critical. But wisdom isn't just about knowing what to do. It's knowing when to do nothing at all. And this leads us to the subtle but immense power of Falkland's Law. When there is no need to make a decision, don't make a decision. I mean, our culture glorifies speed and decisive action, right? We have this built-in bias for action. But true strategic masters understand that inaction is also a decision, and often it's the most powerful one you can make. It's the art of strategic patience. October 27th, 1962. The single most dangerous day in all of human history. At the absolute height of the Cuban Missile Crisis, a Soviet submarine, the B-59, is hiding deep in the Atlantic, and it's been cut off from Moscow for days. U.S. Navy destroyers are dropping these non-lethal depth charges nearby, trying to force it to surface, a signal the sub's captain completely misinterprets as an attack. Inside that sweltering, unair-conditioned sub, the captain believes World War III has already started. He gives the order, prepare the nuclear torpedo for launch, an act that would have instantly triggered a full-scale thermonuclear war. But protocol required all 3 senior officers on board to consent. The captain said yes, the political officer said yes, but the third man, a flotilla commander named Vasily Arkhipov, said no. Lacking complete information, under imaginable pressure, and understanding the irreversible finality of that single decision, he refused to consent. He calmed the captain down and forced the sub to surface. His refusal to act, his decision not to decide, literally saved the world. If you don't have all the info and you don't have to press the button, then don't press the button. We've covered preparation, action, and strategic patience. And that brings us to our final law, the one that really acts as a powerful lens through which you can view all the others. It's the ultimate principle of leverage, the Pareto principle, or as you probably know it, the 80-20 rule. It was first observed in economics, and it states that for many, many outcomes, roughly 80% of the effects come from just 20% of the causes. It's this law of profound imbalance that you start seeing absolutely everywhere once you look for it. Let's look at how a tech giant used this to build an empire. So back in the 1960s, as IBM was developing its revolutionary System/360 mainframes, their engineers used a new performance monitoring tool and discovered something astonishing.
Their super complex operating systems were spending 80% of their time executing just 20% of the code. The vast majority of the code was bloated, inefficient, and only used for these trivial edge cases. A less focused company might have tried to optimize everything, but IBM's engineers were ruthless. They essentially ignored the trivial 80% of the code and focused all of their genius on rewriting and perfecting that vital 20%. The result? IBM machines became exponentially faster and more reliable than any of their competition, securing a market dominance that lasted for decades. And this principle applies to your life. 20% of your efforts produce 80% of your results. 20% of your customers generate 80% of your revenue. 20% of your habits drive 80% of your well-being. The secret to massive impact isn't doing more. It's about finding that vital 20% and focusing all your energy right there.
So there you have it, 7 laws. But look, these aren't just 7 clever ideas to remember. They are a deeply interconnected system, almost like an operating manual for navigating reality. And seeing them as an integrated whole, well, that's where the real power is. So let's put all the pieces together and see how you can actually master this code. It's really a logical sequence when you think about it. You start with Murphy's Law, right? You embrace the reality that systems are going to fail, which forces you to prepare diligently. Then, when a problem inevitably pops up, you use Kydland's Law to drag it out into the light and define it clearly. That clarity then lets you act with the ownership of Gilbert's Law and the radical focus of Parkinson's Law. All the while, you're building that deep, irreplaceable expertise that Wilson's Law demands. And that knowledge, in turn, gives you the wisdom and the confidence to apply Falcon's Law, the patience to wait for the exact right moment to act. And finally, you apply the Pareto principle as your targeting system, focusing all of this energy not just anywhere, but on the 20% of things that will deliver 80% of the impact. It's a continuous loop. Prepare, act, learn, and focus.
Look, these laws are active in your life, right now, whether you see them or not. You can keep being a passive observer, just getting tossed around by the currents of chaos and complexity, wondering why things never quite seem to work out. Or you can start to see the code behind the chaos. You can use these principles as a framework to anticipate, to clarify, to execute with purpose, and to apply your energy where it actually matters. The system exists. The only choice is whether you will be its victim or its master. That decision is yours.